Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along.
Hi, I'm Brad Kubin, Editorial Director of MetalForming Magazine here at the Precision Metal Forming Association. It's my pleasure to welcome you to the next edition of our MetalForming Live series of panel discussions. Today we're going to be talking about recent advances in advanced high-strength steel grades. And then we're going to turn the conversation around to some best practices and how to equip your press room to best handle these advanced steel grades. With me today is Lou Kren, our senior editor. Lou did a good job of putting this event together, did some interviews with some steel experts, and then we've got Jim Myers on the line from TCR Integrated Stamping, and he's going to be able to lend his expertise to the discussion, particularly with how to equip your press room to handle advanced steels. Before I turn it over to Lou, I want to remind our online audience, as we always do, that these events are really meant to be participatory by our audience. We want you to ask questions of Jim. So please, as we're going along here, make some notes about questions you want to ask, or go ahead and put your questions into that Q&A panel, and we'll address them at the appropriate time. So get the most value out of this as you possibly can by shooting your questions over to us. So without further ado, then I'll turn things over to Lou.
Okay, thanks, Brad. As we discuss advanced steels and considerations for their use, I thought the discussion should start with recent and coming developments in the world of higher strength steels. For that, I recorded a recent visit with the American Iron and Steel Institute, specifically Dr. Hisham Azat, Senior Technical Consultant Automotive Program, and Brian Esterberg, Senior Automotive Marketing Strategist. In our 20-minute conversation, we discussed recent advanced steels developments, how metal formers can access information on these newer materials, and what's coming steel-wise in the next few years. Let's take a look. Dr. Azat, can you describe recent current advanced steel developments by steel makers to address lightweighting, formability, and other issues, and how are they being incorporated into vehicle designs?
Sure. Thanks, Lou. Just let me start by saying I appreciate you inviting me to join you here. And let me start by saying that the steel producers worldwide have been very responsive to the needs of the global automakers and their tiered suppliers by offering them a wide variety of steel grades, allowing them to manufacture high-quality vehicles and keep pace with, as you know, the continually changing requirements landscape. So the steel industry over the past several decades was able to provide this broad spectrum of grades with different strength and ductility characteristics, doing that by tuning alloying elements and the thermomechanical processing parameters. So for simplicity, if we were to arrange the grade families chronologically, we start with the conventional highly formable low and high strength steels, including mild and bake hardenable grades, and HSLA steel grades, which were a little bit higher strength. Then we move on to the more widely used currently advanced high strength steel grades, which include dual phase, ferritic benitic, complex phase, martensitic, trip steels, and hot formed steels. These grades offered improved formability over a wide range of strength as compared to the previous grouping. And then we follow that by what is known now as the third generation advanced high strength steel group, which includes multi-phase steels engineered to provide enhanced formability, typically relying mainly on retained austenites in a bainite or martensite matrix. So essentially, you got these different grades, and each grouping essentially has its application where it might be best suited to meet the functional requirements of any specific automotive structural component. From an automaker's point of view, however, if you look at it, they're all about balancing the functional requirements, and the manufacturability. And that includes both forming and joining, by the way. So it's not exclusively forming. So any steel selection for a structural component will depend on, number one, its location within the structure and also its primary function. So for example, if I look at the highly formable, mild, and baked hardenable grades, these are best suited for styled panels with considerable draw depths and crisp features and sharp radii. Meanwhile, if I look at components whose function is managing crash energy, like front motor compartment rails, these would probably need grades, steel grades that have high strength and ductility. So we could throw in here, for example, dual phase steels would be a good fit. Finally, for structural components that are required to resist excessive deformation and prevent intrusion, such as A-pillars, B-pillars, roof side rails, rocker panels, etc. These basically are where ultra high strength steel grades are preferred. And that's like, to prevent any kind of intrusion or excessive deformation during rollover or side impact events.
Mm-hmm.
Meantime, in addition to just providing the sheet steel, I'd like to say that the steel industry works closely with the automakers and the part supply base on advancing the state of the art in manufacturing through innovative technologies such as hot stamping, which really is an up and coming, as you know, technology that allows the production of ultra high strength components with complex geometries and virtually no springback. And also, tailored welded blanks is a technology which is really getting a foothold in the industry. This not only allows you to do a mass optimization, but also allows tailoring the performance characteristics of the component. On the other hand, however, I should also note that the steel industry is working hard on addressing environmental concerns by focusing considerable efforts on producing the same high quality grades with lower emissions. So as we know, as we all know, that the regulatory narrative currently continues to shift slowly towards the reduction of greenhouse gas emissions into the atmosphere. And in turn, the automakers will be seeking material systems that support their targets for emissions. So known for its sustainability and with the ongoing efforts by the steel producers to reduce emissions during the steelmaking operations, once again, I believe strongly that steel will prove to be the best material to manufacture cost-effective, mass-efficient, environmentally friendly vehicles. So in summary, this continuum of steel grades that I just laid in front of you, the industry offers currently enables automakers to not only meet but also exceed in some instances their targets for safety, mass efficiency, durability, manufacturability, quality in a very cost-effective and sustainable manner. I do expect this trend to clearly continue into the future with the continuous evolution of the steel grades. I hope that kind of answers your question in a very general sense.
Absolutely, and obviously, steel producers are they're working constantly to on these developments. Now, from a metal former's perspective, how can metal formers access information on how best to work with these advanced grades and new steel developments?
Oh, okay. So there are a number of options available for the metal formers and the part producers. So for example, the AISI website at steel.org offers some technical resources under its automotive market. A GDIS, Great Designs in Steel, searchable database of past presentations by experts in the field and recordings of GDIS technical webinars can be helpful in that regard and can be accessible through the AISI website. Also, they can visit autosteel.org, where they can find technical training webinars that are offered regularly if they would like to register and attend these webinars. That site also offers other videos and educational content for their review. Another thing that comes to mind is AHSS Insights, that Advanced High Strength Steel Insights.org, which is an online resource for technical information on advanced high strength steels for automotive applications. If you recall in the past, I don't know if you remember, in the past there was a book that was called Advanced High Strength Steel Guidelines, Applications Guidelines. This kind of like it kind of replaces that. It's the electronic version of that. This features a searchable database which enables easy access to critical information on metallurgy, forming, and joining. It's made available publicly by World Auto Steel, which is the automotive arm of the World Steel Association. Hopefully this helped a little bit.
Yes, absolutely. And now looking to the next few years, the next, say, 3 to 5 years, what developments such as artificial intelligence will make an impact on advanced steel production, its incorporation into vehicle designs, and its use by metal formers?
Okay, great question. Let me say that to ensure that steel remains the automotive material of choice, our steel producers will be continuing to leverage any and all technological advancements that will help them deliver the grades that assist the OEMs to successfully navigate future regulatory and consumer-driven requirements, while achieving their cost imperatives without compromising all of the other performance imperatives, including greenhouse gas emission targets. So, let me back up a little bit and look at the broader picture for now. I know that the focus is really on AI and machine learning, which is absolutely spot on. But I would like to take a step back and look at the big picture. We've all undoubtedly heard of Industry 4.0. And Industry 4.0 refers to the integration of a number of advanced technologies such as cloud computing, the Internet of Things, big data and analytics, digital twins, which could be very useful for our metal formers, artificial intelligence and machine learning are among those technologies. Now, specifically, artificial intelligence and machine learning has a particular relevance to our topic here that we're talking about, specifically from a steel and automotive perspective. But the aim of this whole thing is to enhance manufacturing efficiency and streamline industrial processes and logistics. So the whole thing is all about improving efficiency. And I know that you've probably heard that this is called the new industrial revolution or something like that. So basically what we're witnessing here is a huge opportunity to revolutionize our industry, which is the steel and automotive applications and part manufacturing, and improve the product quality through faster and more efficient operations. So if the primary objective is for us to improve productivity, efficiency, flexibility in manufacturing, and enable customization and smarter decision making, it is pretty easy to see what the future holds for steel producers, part fabricators, and automakers to significantly boost their already successful collaboration that we've been witnessing over the past few decades. So starting with steel making, in order for them to ensure production efficiency, improve quality, and enhance consistency and reliability, I believe the steel industry will be leveraging all aspects of Industry 4.0, primarily artificial intelligence and machine learning, to further fine-tune their production processes, streamline the product inspection processes and procedures, and provide high quality grades that improve both global and local formability for more accurate and consistent part production. So in particular, if I look at artificial intelligence, which is fueled by big data, which is clearly one of the criteria here, it's kind of backed up by a huge collection of data. Artificial intelligence will be instrumental in optimizing and automating steel production by allowing producers to refine their steel grade, chemical compositions, and dial in process parameters, monitor their processes, and detect in real time anomalies to be able to take the appropriate corrective action, enhance their final inspection and quality control of their product. And then the most important thing, which is relevant really to the entire automotive world and to the metal forming world, is to generate and allow or help the producers to generate and provide accurate constitutive and fracture data for the use by engineers and analysts at both part fabricators and the OEMs to be used in their simulations. That last point is really a key, and I think AI and machine learning will allow us to do that consistently and with great degree of accuracy. From a part fabricators and a metal formers perspective, on the other hand, I believe they can leverage artificial intelligence, machine learning, and digital twinning or digital twins, which is virtual replicas of their physical systems, to analyze material and part data, monitor equipment health, update tool designs, and adjust their machine parameters to produce first-time high-quality parts. Automakers will use all components, and they've been attempting to use those for quite a while, of Industry 4.0 in a similar manner. And in particular, if you look at it from an artificial intelligence perspective, it will allow them to generate multiple design iterations based on a wealth of historical data, run their rigorous safety analysis, conduct virtual performance tests, and assess business case imperatives in a much shorter time frame. So basically cutting down on the development cost, cutting down on the development time. From a plant point of view, the body shop processes, the paint systems, the general assembly systems will also use machine learning and artificial intelligence to conduct real-time inspection, feedback loops to achieve the targeted quality metrics. So in short, in the future, this entire continuum of the vehicle development process, starting with sheet steel production and material characterization, moving on to formability and part production, moving on to safety simulations and NVH analysis, durability analysis, mass and cost optimization, manufacturing parameters, joining and assembly, quality control and inspection. All these will definitely benefit from particularly artificial intelligence and machine learning. The end result is to produce really high quality vehicles in much shorter timeframes and at a reduced development cost. So let me point out that the ultimate development tool in the past, at least in my past, the ultimate development tool that automotive design and manufacturing engineers have always aspired to is what we call a true multidisciplinary optimization, which allows the simultaneous optimization of design, performance, manufacturability, material utilization, mass, cost, etc. And I do believe that AI, with this, fueled by this huge big data behind it, will finally provide a path towards this goal. And I'm glad you bring this up, because now I can ask my colleague Brian Esterberg to comment a little bit on something, the events that happened at GDIS this past May, and also some upcoming events. Brian?
That's great.
Thanks, Hisham. I appreciate the overview. And yeah, for those of you that might have missed Great Designs in Steel this May, we had a artificial intelligence panel among about 25 other technical presentations. And as Hisham alluded to, those presentations are available as a resource publicly at autosteel.org at our website. There you'll also find information about our upcoming webinars, two of which are actually focused on the topic of AI that Hisham's just been talking about. If I could just mention, July 29th, we have our next GDIS technical webinar presented by Cleveland Cliffs. It's a comparison of 1500 megapascal ultra high strength steels for automotive applications. It really begins to look at formability and understanding ductility of cold formed ultra high strength steels. So you don't want to miss that one. September 9th, our next webinar addresses artificial intelligence titled Towards New Automotive Steel Developments Driven by Big Data and AI. That's by Fadi Abdulfarah from Material Insights, who was on the panel at Great Designs in Steel and set up a great primer for us there. Following that, October 21st, leveraging artificial intelligence for optimized vehicle structure design with advanced high-strength steels with Dr. Shengdong Li from Generality, who again was on the AI panel, had some great insights, and we're really looking forward to both of these deeper discussions on the topic. So again, those resources are available at autosteel.org, and we welcome you to check those out.
Great. Well, thank you both very much. I appreciate this information on what's recent, what's now, and what's coming in terms of steel production and its incorporation into vehicles. And again, thank you, Dr. Azat, and Brian as well, for taking the time to be with us here today.
My pleasure. Thank you.
Always great to talk with you, Liv. Thanks.
Okay.
Okay, great conversation with Dr. Azat and Brian Esterberg, both from American Iron and Steel Institute. And now I'd like to reintroduce Jim Myers, Senior Stamping Engineer with TCR Integrated Stamping Systems. Hi, Jim.
Hi, guys.
And now, can you tell us a little bit about yourself and TCR and your involvement in helping metal formers work with these advanced steels?
Absolutely. And again, thank you to you guys, for having me on today and allowing me to be a part of the presentation here. It's always a pleasure. I guess a little about me. My work history is pretty much centered around contract stamping in the southeastern Wisconsin area. I was in engineering for stamping for about 30 years or so until I guess jumping over the counter to getting into some equipment sales with TCR. Primarily, I work for TCR, utilizing those years of experience to help our sales team and help our customers dial in on the equipment that makes the best sense for their applications. TCR specifically, our focus, as it is in the name Integrated Stamping Systems, is we try to take a look at stamping operations on the whole, or just specific applications, and try and find the best fit of equipment for the application to help our customer and help them get the best production system for their operations. Whether that's just with, a press specifically or the materials that are around the press. I mean, or taking existing equipment that they have there and giving them the tools to improve their operations around that.
Well, thanks a lot for that
Yeah.
introduction, and Jim, we'd like to pick your brain a little more, so we're gonna spend some time here doing that. We took some notes from the AISI presentation, and part of the conversation there had to do with simulation and efforts being done to make simulations more robust, leading to better performing dies and greater forming capabilities. Can you provide maybe some comment on the importance of providing better data to improve simulation and why that's so important for forming these advanced steels?
Sure. I mean, the best thing for simulation in general is good, accurate data, right? And specifically speaking to material properties, we've all heard the old adage, garbage in, garbage out, right? And so having good data and having a good understanding of the material and its properties will always provide you the most accurate simulation. We just recently were working with one of our customers to do not a high strength. This was a deep draw application, but again, we wanted to understand what their material properties are and make sure that we give the toolmaker the most accurate information. And the customer was able to provide us with specs over a couple different lots so that we were able to zoom in and understand what the data was in order to give them an accurate simulation for us to determine tonnage for presses and what kind of equipment they're going to need. So accurate specifications or actual certifications are good. Lab tested properties of the real material will pretty much always give you the most accurate picture, but also safe to remember that can vary. Those results can vary lot to lot on your steel.
Mhm. Okay. And now die designers and builders, they also benefit from that more robust information about materials. And from what you've seen or been a part of, and in terms of these new steels, what new thoughts or considerations have you seen out there in terms of die designs?
Well, with some of these advanced high strength steels, there are some differences to be considered for sure. Some of them are using some of the more advanced tool steel. So a few years back, DC53 was brought out as an alternative to D2, which had some better properties for higher strength steel. Caldi is another material that is out there that they might consider. They could be looking at powdered metals. There's a whole wide range of powdered metals that might work better with these steel, or should work should work better with these steels. There are a tremendous number of different tool coatings available and surface treatments for steels. So, as you work with these, we years ago using just grade 50 punching, we tried 4 or 5 different coatings in order to improve stripping off of punches and die wear and all those things. There are other considerations for die clearances may need to be a little bit different for some of these newer steels. And overall construction of the tool could differ using, simple things like thicker die shoes to eliminate variation or whatever, and possibly adding thicker or possibly alloyed backup plates in the dies to provide greater stability for the tool itself.
Jim, can I ask you a follow-up question when it comes
Absolutely.
to the material properties? From all the stampers that you visit on a regular basis and over time, how often do you come across stampers who really understand the need to gather material properties prior to starting production or even starting die development? Is that becoming more understood in the industry, and more stampers are doing that and going outside to labs to get material tested?
I would say, boy, that's kind of hard to say. It is not completely normal for us to get into tool development. From our standpoint at TCR, we need to understand what the tool is before we can help with the press. That's kind of a big thing we go by. But generally they'll have, most of our customers will have those things ready to go. So I would say a lot of them do understand what the material is, and you can, some places you can tell just in conversation. Some places are still, we just get in and we get it done. And then there are other places that definitely have more advanced quality systems that will force them to gather more data on the steel, and understand what they're using to provide better part quality going down the line. And some of that is relative to a lot of smaller shops. They have learned to work within the parameters of what's available, right? So they can use a steel, a regular steel spec has a fairly wide range, and they can work within that range.
Good, thank you.
Mhm.
Now, Jim, if we could maybe move down the press line, so we could, gather some of your expertise in that of TCR and, all along the press line there. And it starts right at the beginning with the feeding of material, feeding, straightening, those functions. If you could kind of take us through, some of the recent advances in that type of equipment and what advances make sense for people who deal with, these higher strength materials, and what considerations do metal formers have to take when, opting for this type of equipment?
Sure. So let's talk about feeding first, right? Because that's where we go from, that's where we start. And if you look at the older coil lines that are out there, older feed lines that were built with mild steel and maybe even some of the high strength steels in mind may not work as well with the advanced high strength steels, just simply because of the higher forces needed to straighten that material, right? And especially with some of the thinner material that they're using, because that's part of the driver is getting the weight down. So you go to thinner materials that are higher strength. The thinner materials require, smaller rolls closer together. And with older machines, smaller diameter rolls mean that there's going to be some deflection and some variability in the material as it comes out. Some of the newer equipment that's out there available now is purpose built for straightening and feeding these types of steels, because they have increased power, larger backup rolls to support the forces needed to straighten the material, increased capacity for depth of penetration in the straightening rollers, increased force capacity and roller adjustment specifically. I mean, just to be able to push that roller down into the steel requires more tonnage. So then that leads right back to increased bearing sizes and gear sizes that are on the machines, and thicker support structure all around that. One manufacturer that we work with specifically, purpose designed new roller adjusters, because they were using an off-the-shelf roller adjuster that was fixed at, I don't know the exact dimension, but it was fixed at a size. And in order to straighten these advanced steels, they needed to get the rollers closer together. And so they had to purpose design roller adjusters to be able to provide more force closer together. They were able to design this, get it to happen. It increased the penetration of those rollers by up to 45%, and then just the bearings and the structure around it, they had increased the sizes by 10 to 15% all the way around in order to be able to work with these steels.
Is that a one-off development, Jim, or
What's that?
Is that a one-off development, a custom machine, or is that something that might be commercialized?
No, that's commercially available. That's a standard model. Standard models. It's just, most feed companies, they'll have the different models, but yeah, in this case, it's a standard model for them, and they can, they'll produce that for you should you need it. Yeah.
Mhm.
Because they had to respond to the materials as they're coming through, right?
Sure.
So they really looked at what do they need to increase and improve to do that. I guess, taking it from feed to the press next. One of the, I like to think one of the biggest enemies of press is high reverse load. And that is, when you're blanking and you're pressing through, it's that compression. A press is built for tension, not necessarily compression. And cutting these advanced high strength steels can create major reverse load due to sudden breakthrough. That a lot of these, typical steel you push through and you get about 30% through the material before it breaks. And some of these newer materials, they break right away. They just snap. And so all that tonnage is released immediately. Important to remember, advanced high strength steels have a positive strain rate sensitivity, meaning the material gets stronger as you run faster. So increasing your blanking speed requires more force to cut. So, we all want to go faster. We want to make, you want to hear that press pounding and making money, right? And the faster you go, the higher forces you need. So couple different solutions, right? You can upsize the press to accommodate that. For the forward tonnage, you could add shock dampeners to help you with the reverse tonnage, and those are some simple things. But one of the greatest advances to answer that is the servo press. With the servo press's ability to control ram velocity and the stroke, it's going to benefit both forward and reverse tonnage. We at TCR, we regularly see reduction in forward and reverse tonnage simply by just reducing the ram velocity near the point of impact. And that's huge with the servo press. You can come down quickly, you can get real close and then slow it down, pop through, and then take back off and keep things moving and keep all that movement outside of the working part of the stroke moving quickly. And in some cases, you may actually be able to create a program that runs faster than a standard mechanical press, even with that slowing near the point of impact and maybe shortening the stroke a little bit. So that, by slowing that snap through down, that decreases the reverse tonnage tremendously. And also, like I said, we've seen reduction in forward tonnage on the way down.
Jim, can I flip back for a second to Dr. Talking about AI and digital twins? I'm wondering, in particularly when it comes to feeders and straighteners, have you seen applications for digital twins to make sure the straightener, can you simulate straightening an advanced high strength steel and use that to design the rollers and the amount of power that you need and the size and spacing of the rollers? Have you seen that?
I have not personally seen that. No. Not to say that it's not out there or available. But it's not something that I have come across yet.
Yeah, I kind of feel like we will fairly.
Yeah, I believe that. I believe that, we do run into more and more often, where customers are talking about offline programming and stuff like that of presses. And so I think it's just a natural, as the equipment advances and as technology advances, we see it now where we could store, you can walk up to a production system now and put in a part number, and the press takes off and sets itself. The feeder will also take off and set itself. So I think that's just a natural progression in technology.
What about the IoT part of this, using sensors to gather data off the floor from feeds and presses, as the material gets harder and more snap through potentially, and potentially more damage to an expensive servo press. Do you see customers, stampers, gathering more vibration sensing, or making sure they're tracking snap through and reverse tonnage and protecting their investments?
I will say that we probably see more customers going to products like a LinkNet or something like that, where they can monitor the presses and see what's going on and look at why is it stopping. What was it, an over tonnage? That kind of gets to control systems and whatnot. But yeah, we definitely have seen a slight uptick in machine monitoring and over the last several years. Just trying to track what's going on in the shop and get a better handle on why is production stopping and what, using those kind of tools for predictive maintenance and stuff like that.
Thank you.
Sure.
Now, Jim, moving along that press line, we get to things like part transfer, part handling, maybe post operations or just prior to, leaving that press line. Can you talk a little bit about that midline and end line, automation and equipment and how that might be affected by advanced steels and kind of what you're seeing out there?
Sure. Part handling through a die can always be tricky, right? And there are cases that I could see, and I think we're running into that maybe from time to time. Where in the past you could have a carrier and run something progressively, where you might need to consider a transfer instead because of the properties of the material being maybe a little more brittle, little harder to work with, that maybe you can't have a stretch web on a part as I see Brad laugh. No, you can't have those kind of things on there that they might break and cause problems, in which case you'd want to move to and consider a transfer instead. Looking at as you go down the line, it may be a better transfer might be a better choice, in applications where that progressive part carrying might not work. We talked, previously we talked a little bit about hot stamping. We haven't run into that a whole bunch, but I mean, absolutely in cases where that part might be preheated, transfer is certainly an important consideration, or at least for part handling coming out. And proper end of line automation or conveyance out of the press is always important to us to be able to make sure you're maintaining your production rates.
And, of course, tying it all together, and, we discussed this a bit earlier, the controls aspect of it, this material doesn't come super cheap. The equipment to run it isn't super cheap, it requires investment, the tooling, everything along that line. So, obviously you'd imagine things are more dialed up in terms of, sensors and controls and everything else. So if you could talk about, a little more about the controls aspect and the ability to, gobble up all this information from the sensors and everything throughout the press and the process.
Sure. And like we just talked about, well, good control systems are always very important for all your stamping operations in general. And like we talked about collecting machine data, the better control systems you have in place, the better that will allow you to collect that data and make good use of it. Specific to high strength steels, my thoughts would be tonnage monitoring and speed control. I mean, sensors, of course, we'll talk a little bit about that, but tonnage monitoring and speed control, I think, are really important. Variable speed can be real important to stamping these kind of materials because, or specifically, as I mentioned, as it relates to servo presses, speed control is going to be real advantageous for you. If you have just a variable speed press, you could slow it down a little bit and hopefully give your press less of a beating. With a servo press, you can control at different points and potentially be able to get better production rates, even though your working envelope, you're slowing down a little bit. Tonnage monitoring can tell you volumes about your operation, and most important there again is reverse load or over tonnaging to avoid damaging your machine. You don't want to do that. Secondly, you can also use tonnage monitoring to monitor tool wear. You can observe the tonnage signatures of your operations, to watch for trends in tonnage to help with tool maintenance, verification of correct setups, etc. And somewhere, if there's a significant change, if you have a recorded tonnage signature of this part, if there's a significant change in there somewhere, it could indicate broken punches, or maybe a tool is galling due to working with these higher strength. You'd be able to really understand the signature of how your part runs and be able to set the parameters of the tonnage monitor to kind of control that and stop the press and prevent scrap parts or further damage to the tool. And always, a robust sensor program is always advantageous to any stamping operations, and controls that support those sensors are important to anyone's success. So I mean, I would encourage any company that doesn't have a robust sensor program to start looking at that, because, if you want to get the productivity and the repeatability of your stamping processes, that's always important, and probably more so yet, even with these materials.
And, with metal forming, we always talk about the importance of versatility and capabilities in terms of your equipment and what it could do. And it allows metal formers to reach out and capture more markets. So with lines that work with these stronger materials, how versatile are they? I mean, like, running mild steel or these, super steels. I know there are so many equipment demands there for these newer type of materials, but can you talk a little bit about how flexible the equipment is, like going back and forth between, tougher materials and not as tough materials? Does it require
Sure.
different lines, or?
I mean, I would say anything, if you've designed a line to run high strength steel, I mean, obviously optimized for that kind of stuff, but you should certainly be able to run lower strength steels on those as well. Standard specifications and whatnot, with little or no trouble, right? Because it's just going to be less wear and tear on that equipment, right? So, going back to the feed, you've overpowered your feed in order to be able to overbend this high strength material to try and get it straight, and you would just back off on those things a little bit in order to straighten the regular steels. If you're not going to run the high strength steels, it's not really necessary to look at all those options. But again, other than maybe a servo press, I'm a big proponent of servo press, and I think, one servo press could easily replace 2 mechanical presses in the field out there but also my background is contract stamping, and I understand that versatility is key. So, I would think any line that's optimized to run the high strength steels would probably handle standard specs without much issue.
Jim, when it comes to tonnage monitoring, you spoke about that, plenty.
Yeah.
I can see how tonnage monitoring would be even more critical with these higher strength steels. How intuitive is it, based on your experience and with your own shop and with your customers with TCR? How intuitive is it to properly set up a tonnage monitoring system and then properly follow up on the data that you're receiving? In other words, I guess I'm looking for some best practices, tips that you might tell people if they're not really actively using tonnage monitoring today, if they're going to start using it for these steel grades. What are some of the things that they should look for when they're setting up the monitoring system and then using the data?
Sure. I mean, with your machine monitoring, you can look at that, but real basic, some of it comes in setup, right? So if you're running a progressive die per se, when you're setting up a new coil, there's the key component of letting the tonnage monitor learn what where that range is, and then taking the time to set those parameters in the controls as to, I can accept plus or minus 5% or plus or minus 10%. And as you run, you could sometimes tighten that up a little bit and understand, I'm going to have good parts within this range. One of the shops that I used to work for years ago, that was kind of where I really started getting introduced to tonnage monitoring, where we just had a tonnage reading. It was a total tonnage in all four corners on our setup sheets, and I saw the importance of it there by just telling the setup person that they had to check that as part of their setup, right? They put the material in, they checked it, and it needed to be close. It needed to be within a range, within an approximate a couple of tons of what that setup was. And we almost always got a good part as a result of that. Now, that being said, material properties, when you're buying, commercial steel, right? It could be here to here. Rather than buying something that's tightly specified. And so that could change those properties, but it was always a great place to start. We get the shut height set, we get everything dialed in, we understand where we're at. Yeah, the tonnage is pretty close. We checked the part and very frequently it was good. And then from there, it was on our progressive operations. Are we, taking the time to set that up, watching what the tonnage signature is, looking at the tonnage curve, or something happened. We get an error. Well, where do we go back and look? We can go back and look at a couple of hits in the control and say, okay, 5 hits ago, something changed. And then we can look in the tool and say, oh yeah, okay, this broke. But that is only if you have the discipline to make sure that you're utilizing those tools, right? They're there, and it is important to use them if you have them. I think it is, but a lot of stampers will overlook some of those things, and it all comes down to making sure that your people are using the tools that are given to them. And making it a standard part of your process, so it's not something I need to think about using. It's just something. This is just something that we do every day, and making sure that you instill that in your business process to make sure that those tools get used.
Yeah, that makes sense. So as more and more stampers start to look at using sensors, then you start hearing more stories about nuisance faults, and we wanted to do sensing, but we can't quite figure out how to avoid nuisance faults. We don't know what to do when we get a nuisance fault. Do we overlook it and keep running, or do we really address it? And Lou's just put together a nice article on that topic actually for the August issue of MetalForming. But so yeah, you are. But so do tonnage, does tonnage monitoring potentially lead to nuisance faults, or that's not a thing with tonnage monitors?
I mean, I guess it can, right? And generally, in general use, you have, you understand what your tonnage is, and you can set an upper and a lower limit to it. And over the course of time of running a part, you could determine, maybe I could tighten up those specifications a little bit. But if you're getting a fault, generally that means something's changed, and it's up to you to determine, maybe you can allow a little more change in your process. So maybe you need to open or close the window, or open it on the top side, open it on the bottom side, whatever. It is just having, I guess, making use of that data. And we all know places that have collected tons and tons of data and never done anything with it, but and it's unfortunate, but I think it could potentially lead to some nuisance faults if you're not making use of the data, right?
Well, thanks, Jim. We do have plenty of time if the audience has questions. If not, we'll let you go. But any questions from the audience? This would be your opportunity to use that Q&A panel.
I would just like to say, Jim, thanks for joining us. I know there's so many issues that, in our short time here, we didn't even get a chance to touch on too much. Things like lubrication, even the business end of procuring these types of materials, with the EV situation, the demand for these types of parts moving forward that require these materials. So these are all great conversations, and we'll be having them in the pages of metal forming and at our groups and conferences and get-togethers as we go along. Any final thoughts from you on maybe something we haven't touched on, or something you'd like to reiterate?
I will talk a little bit about lubrication. I think, this doesn't apply specifically, I guess, to advanced steels, but I mean, it certainly it applies to all, but it can apply to this. Is understanding understanding the lubricant that you're using and working with your lubricant supplier or the manufacturer of your application equipment, and bringing them in to understand your application as you're using it, and help them understand the problems that you're facing, right? We're working on a project right now, and it was very important to the customer specifically that the tool needs, they have found in their practice that the tool needs to be lubricated, and they're right now using spray bottles and whatnot to do that. And so we're working with them and the lubricant equipment supplier to try and give them the right equipment going forward for process improvements. And having a good understanding of what the lubricant is. Do we need to dilute it? What's the best way to use that? Or is it even the right lubricant for your application?
Do you get involved at TCR then in helping select the lubricant itself for, in this case, an advanced high steel application?
We may get involved in it. In most of the cases where we're involved, we may recommend something if we're asked. We may recommend something, and we will get involved in the this is what we use. Okay, great. Give us a sample of that, and then we'll work with the application, or with the application engineer at the equipment manufacturer to make sure, okay, this is what you're currently using. Can we spray it, roll it? What is the right application? How can we optimize your lubrication use so that you're not just dumping, the last thing you want to do is waste expensive lubricant, right? So, we'll get involved to the specifics of how much are you using, and we may come back, from testing and say, hey, there may be a recommendation to look at something as an alternative.
Excellent. Yeah, we do have a couple of questions related to lubrication. It might be a little bit outside of our realm here, but
Okay.
Based on your experience then, when it comes to lubricant selecting or helping your customers select the right lubricant for an application, are there specific needs that you see out there from the lubricants that are not becoming available to stampers? Do lubricants need to have different properties than we currently have available, based on what you see?
Based on what I've seen, I mean, there is something out there for everybody, right? Most lubricant suppliers, from what I've seen, have such a wide range of different things available. It's I think you'd have a hard time if you couldn't find anything. If one company doesn't make it, I'm pretty confident that another company can or will or does already. There's just such a wide range. Just from my own experience, there's such a wide range of lubricants, and then seeing, it's kind of hard to choose just one.
Yeah, I hear you. And then the next question has to do with simulation, and it's probably a question better left to the auto forms of the world. But I do think that when it comes to process simulation, for die design and development in particular, there's a lot known about these lubricants. They can input the material properties into the simulation program, and They can even account for, to some degree, I think, heat buildup in the dies that runs. I think there's probably some more development that might need to go on. That, if autoformers here, they could probably fill us in a little bit better. But I knew I know there's advances going on with how to simulate the behavior of the lubricant during stamping of advanced steels. I know that's probably outside of your comfort zone a little bit, Jim, but unless you
Yeah, I have worked with tool shops to provide specifications for simulation. In my experience, I have not been asked to discuss the lubrication of it all. I've certainly been to the point where we've gone and taken coupons from our material and send it out for third-party lab testing to make sure that we're getting real accurate results on simulation. But yeah, I can't say that I've had to use or input any or had to consider the lubricant in simulation before.
I got you. All right, well, if there's no more questions from our audience online, I'll second Lou's thank you to Jim for hanging out with us today for an hour or so. Also thank our friends at AISI for recording those sessions with you. A lot of good information there. And thanks again to our attendees for spending some valuable time with us today. Please be sure to join us for our third edition of our summer series of Metal Forming Live on July 22nd, so 2 weeks from today. Same time, 2 o'clock Eastern, we'll be online to discuss automation applications. Specifically, I think a hot topic is as I'm looking to automate end of line or perhaps feeding of equipment with blanks, or do I use cobots or robots? And that's a discussion we're going to have on July 22nd, helping companies decide what's the right way to automate some of these operations. Cobots are coming on strong, but there's still applications where conventional robots make sense. So we'll tackle that again on July 22nd. Jim, thanks again for joining us live. Really appreciate your time.
Thank you guys.
Nice
Appreciate
job
being a
today.
part.
Yep. And you take care. And again, thanks for everybody for joining us. You can go ahead and close your browsers now.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside.